Okay, I think I can record. So we're recording now. The reason I'm recording is because I'm not doing the same questions as in my own tutorial. So I want my own students to see the questions I'm doing here as well, so people can benefit from both my tutorials and Dariya's tutorial. But today we are going to do contradiction, and we will go over some proof techniques. So before we start with any question, let's review a little bit. So we have 3 different proof techniques. Did I not? I feel like I forgot to send you the tutorial worksheet. So hold on. I'll send it to you. Yeah, I forgot about that completely. Here. See in the chat. I see some familiar names. I feel like my students are also here. So you guys had me for 3 hours today. I know some of you have me for 4 or 5 hours already today, because some of you are also in my 223 tutorial. So you're probably hearing my voices and seeing me for the whole day. Anyway, 3 proving techniques. The first one is direct proof. Direct proof is most of the proofs you've seen so far. So we're not using anything. We're not using contradiction. We're not using contrapositive. Those kind of proofs are really really simple, and they are usually, in this course, they're usually about divisibility. Okay, usually in this course we talk about if this is divisible by the other one, then something something something. Those are usually used. We use direct proof directly. We use direct proof immediately instead of contrapositive or contradiction. The second one is called contrapositive. I should have typed it up. This is when you have P implies Q. We know that this is the first time I've seen a question I can solve without help. Okay, cool. Yeah, I think her questions were slightly easier than the questions I do in my tutorial, but okay. P implies Q is logically equivalent to not Q implies not P. Okay, so this is a contrapositive of this. So when you cannot prove this, we try to prove this. And if you are in my tutorial 2 times already, this is the 3rd time, you should know. When do I use contrapositive? I mentioned it many times. When you have, of course, you need to have if and if then statement. Okay, of course you need if then statement. And what else is if something, a really large expression, we tell you prove that if a really large expression is even or odd, doesn't matter, then x is even or odd, doesn't matter. So something like this is really hard to prove directly like this, because reducing something really complicated to a single x is not easy. However, if you start with x and plug it back into this, that's gonna be easy. So if you see something like this, you know we are using contrapositive. Another thing is, well, if you see something not equals to something, then something not equal to something, that's another hint to tell you, oh, that's contrapositive. Okay, most likely they will tell you which method to use in the question, but sometimes they don't tell you, so you need to figure it out which method you want to use. And lastly, we have contradiction. So contradiction is when you assume the negation and then in your proof you derive a contradiction. Okay, so you assume the negation of the original statement, you figure out, oh, it's a contradiction, so it's always false. Then, before AGM, triangle equality, all fall into direct proof? Yes. So most of the proof you've seen so far, they are direct proof. This means when we test you on direct proof is most likely divisibility questions. That's what I'm saying. So it's like a summary of what's going on in 102. Okay, so for contradiction, you are looking for some negation words. So when you see negation words, in your question, negation words such as no, there are no natural solutions, there are no rational solutions, there are no integer solutions. If you see something like that, you know it's contradiction, or something that we do not have this or cannot. Those negation words, if you see it in the statement, you know, oh, probably we should use contradiction to prove the statement. And outside of 102, if you see infinite, okay, that's another word to tell you, oh, you might need to use contradiction because infinite is really hard to deal with, but finite cases are much easier. Okay, so if you've been to my tutorial twice, you should know this by heart already. Let's do the first one. Show that there are no natural solution. This is telling you we need contradiction. So for those of you who already know how to do this question, how do I do this? Tell me, how do I do this? Yep, go ahead.
We first assume the contrary, so there exists a natural solution such that x squared equals 7 plus 4y squared.
Okay, hold on, let me write it down. Such that x squared equals to 7 plus 4y squared. Okay, what do we do next?
And then after that, we rearrange that equation to have two squares equal to a number. And from here, so from here we see that we can move the the 4y squared to the left side, so it becomes x squared minus 4y squared equals 7.
Okay, then what do we do next?
And then we do the difference of squares for the left-hand side, so it will be x minus 2y times x plus 2y equals 7.
Okay, then what's our next step?
Our next step will be saying that 7 is a prime number, and it only has like one factor, like 7 and 1, and it can't be negative because x is an element of natural numbers.
Oh, hold on. X, y, this is not necessarily natural number. Why can we have negative numbers?
Because like if we the only way for it to equal to 7 is to multiply two positive numbers or two negative numbers. It can be either or. Yeah.
So okay, cool. So I'll just repeat what you said. Since 7 is prime, we know the only possibilities are 7 equals to 1 times 7, or 7 times 1, or negative 1 times negative 7, or negative 7 times negative 1. Okay, so we could have those cases. However, since x plus 2y is a natural number, this is definitely a natural number. So this cannot be negative. We can eliminate the last two cases. So we only have the first two cases, but which case do we have? Is this 1 or is this 7? And why? This is 1. Why is this 1? Yes, exactly. So also, since x plus 2y is greater than x minus 2y, we know we can only have x minus 2y be 1 and x plus 2y be 7. Okay, seems like you guys are on top of this. Let me see if there are any questions. Why don't we have y is a natural number in the first line? Oh, you're right. Sorry, I forgot about this. Here should be y, x and y. You're right. We should have both x and y be natural. Any other question? And if the value was 10 instead of 7, would we go through all factors of 10? Yes. So if it's 10, so let's say if this is 10, then 10 equals to 2 times 5, equals to 5 times 2, equals to 1 times 10, equals to 10 times 1, and also the negative numbers. Okay, but again, because of this, you can eliminate the negative parts. And because this is greater than this, so you would have only two cases. One is 2, 5, the other one is 1, 10. Yes, exactly. Do we have to write that we use contradiction? Well, once you reached contradiction, then oh. So usually I would write for contradiction, like here. My style is I would say for contradiction, suppose blah 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 blah. So let's add it. Oops. So for contradiction, but it's not necessary because the proof, you can tell that it's a contradiction proof. So it's not like you won't lose mark if you don't have it. That would be really harsh if we lose mark, because in that case, most of the profs will fail this course if we do that. Would you have to explain why x plus 2y is greater than x minus 2y? It's pretty obvious, so I don't think you need to. Can we say x plus 2y is positive? That's 7 doesn't, it's not really right because, well, 7 does have negative divisors. You can only say in this case, you cannot have negative numbers, the product of two negative numbers. But 7, it does have negative divisors. Does that make sense? So the logic doesn't follow. Yeah, so in this situation, we don't have -1 and -7 as divisors. Okay, so now you solve for this equation. Add them together, you'll get, so this is 1, this is 2. If you add 1 and 2 together, you'll get 2x equals 2. So 1 plus 2, sorry, kind of 1 plus 2 will give you 2x equals to 8. So x equals to 4. Sub it back in. You'll get 4 minus 2y equals to 1, which means y is 3/2. This is not in natural number, so contradiction. By the way, this is a contradiction symbol. I'm too lazy, but now I don't know why I'm writing again. Okay, if you are in my tutorial, you know this already, and you know our emoji, emoji. Can I write bigger? Is this okay? Can I write a bigger symbol? Oh, it's just two arrows facing each other. So what we were saying is this emoji. So, oops, wrong side. Yeah, basically like this. There we go. It's just two double-headed arrows facing each other. That means contradiction. All right. I feel like I'm teaching all of you the weird stuff. let's do, can't really, okay. Let's do the second one. Can't waste time. We have a lot of stuff to do. Go back. Okay. The second one says, prove that there are no rational solutions. This is pretty simple as well. I'm pretty sure all of you know how to do it already. Because natural numbers, add natural numbers, give you natural numbers, but this part is negative. Could be negative, not is negative. This part, it could be negative. So we need to say this part is natural. Because even if those two are natural, this still can be integer, like still can be negative numbers. Okay. Question 2. Let's do this. Quickly do this. Okay. For contradiction, suppose. Copy. If you are in my tutorial, this should be really easy for you already. So I hope this is really easy for you if you are in my tutorial, because the questions are much easier than the questions I did. So hopefully you can ace the question. So suppose there exists x in rational numbers such that x plus x cubed equals to 1. Okay? Now, since we know that x is a rational number, we can write x as a over b. Okay, the next step is really important. Why? Because, well, you need a and b be integers. You need b cannot be 0. And also, you need a over b to be in its lowest term. Okay, this is the same as saying a, b are relative prime. Or if you've heard of greatest common divisor, you can also say that GCD AB equals to 1. Okay, all three are equivalent, so you can use either of them as long as you know what's going on, it's all okay. So that's what you need to assume. Now you can substitute your A over B back into your equation. So that's A over B plus A over B cubed equals to 1. Okay, so this is what we have. Now, this is what I always say. We do not like fractions, we like integers. So you want to get rid of the fraction. To get rid of the fraction, you need to multiply by b cubed on both sides. So you'll get ab squared plus a cubed equals to b cubed. Okay, why do we have this? Because we do not like fractions, we like integers. So you want to get rid of the fraction. Now, what you need to do is you need to discuss cases. First case, a and b are both even. Then they are not relative primes anymore, right? Because they have a common divisor that's not 1. They have 2 as a common divisor. So that contradicts with this. You can say then a over b is not in its lowest term. What does that mean? That means contradiction. Copy, paste. Okay, so you have a contradiction here. Where does it contradict? It contradicts this assumption. So you cannot have this happen. If they are both odd, then what? Then AB squared is also odd. So we have odd plus odd, okay, equals to, what is this if this is odd? If B is odd, then it has to be odd as well. Then you have odd plus odd equals to odd, which is a contradiction because sum of odd numbers should be even. I don't like this. Let's change it to, let's move this to the other side. Sorry, because I like dealing with 0. That's easier for me. Okay, this is better. So I can write less later. So we have odd plus odd minus odd. This should be what? This should also be odd equals to 0. This is a contradiction because 0 is an even number. So another contradiction. Okay, why? Because 0 is even. Can we stop right there? You cannot stop right there. You have to discuss all cases. Otherwise, you cannot say you have a contradiction. Okay? Because, well, if this doesn't work, what about the other cases? If the other cases work, then you cannot say there are no rational solutions. Have to go all 4 cases. So if A is odd and B is even, then we have what? This is odd times even, so it's even, plus odd minus even should be odd equals to 0. Again, contradiction. Okay, for the same reason, since since 0 is even. And lastly, if A is even and B is odd, then what do we have? A is even, so even plus even, right? Even plus even minus odd should be odd. Okay, and similarly, contradiction. Why? Because, oops. Oh, okay, whatever. It's okay. This is weird. Okay, since 0 is even. Now you can say you're done. Okay, so now you can you're done. You don't need to explain. This is pretty easy. You don't need to. You don't need to. Unless the question specifically asks you to prove it, otherwise you don't really need to. Can we do some hard questions now? I'm doing what Dariya wants me to do. So I don't wanna I don't know. I don't think the questions are hard. All of them are pretty simple. Okay, again, I apologize. I apologize saying something right, something's easy. Or this is like bad. Bad. It's not easy. Okay, let's do question 3. Do you guys have any question? Do all the cases need a contradiction? Yes, you need to do all 4 cases and you need to reach a contradiction in all 4 cases. Otherwise, you cannot say you got a contradiction and you cannot say the original statement is true. Okay? Any other question? Do I need a conclusion? Yeah, you better have one, but I'm lazy, so I don't want to write one. You can write one, but I don't want to write one. I'm a lazy TA, so don't expect me to write anything not necessary. Will this PDF be uploaded later with the solution? I think Dariya uploads the solutions, but I'm not sure what she does. So if she really uploads solution, then yeah. Okay. All right. Image problems, we don't have image problems. The tutorial is focused on contradiction, proving techniques. Okay. 3. It asks you to rewrite the following proof without contradiction. Let's skip it. It's not important. I don't like this question, so let's skip it. Sorry. I feel like I'm stalking Lee right now. I'm dumb bad right now. I just joined the TA tutorial and I'm not just get help from a TA filling in for. Okay, bye. You probably joined 2 of my tutorials today already, right? I did not kick anyone. 4. I'm skipping 3, okay? Either you like it or not, I'm skipping it because I don't like it. Number 4. Guys, number 4. Number 4, identify which proof method you will use. What do we use? Look at this. A, if x minus 1 is not divisible by a, then x is even. What do we use? Contrapositive, right? Contrapositive, simple. I just told you this is contrapositive actually. When I talk about contrapositive, I said something like this. So this is contrapositive. Remember I said when they gave you a bigger expression here and then reach to something easy, you use contrapositive. B, if a natural number is divisible by 3, then the sum of its digits is divisible by 3. What do we do? What do we do? B, 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 B. No, you don't need to do. Okay, remember I told you, if you do contrapositive here, you are making it not divisible by 3. We don't want no. We don't want not. Remember? That's what I mentioned, right? We don't want those. We want yes. We don't want no. So it's a direct proof. Okay, it's a direct proof. C, what do we do? C. Some of you put contra. What's contra? Contradiction or contrapositive? Contra, positive. Contrapositive. Here, contrapositive. It again, this is quite long and reached to a really short conclusion about x, so that's contrapositive. Last one, show that there are no rational solutions to x cubed plus. Why do I have a negative here? This should not be here, okay? What do we have? What do we use for this? Contradiction, exactly. Can I prove B? I don't have time to prove B, but if you want the proof, you can email me. I can quickly say how to do it, but we don't have time to write a formal proof, okay? I can quickly tell you how to do it. So if a natural number is divisible by 3, you can write a natural number as like A, B, C, D, E, F, G, something like that. Okay, so each of those are the digit for the natural number. So I'll give you an example. I'll give one example to show you what do I mean by that. For example, let's consider a natural number. 980. Okay, let's say this. This is a natural number. Okay, the logic is you write it as 1 times 10 to the 0 plus 2 times 10 to the 1 plus 3 times 10 to the 2 plus 4 times 10 to the cube plus 5 times 10 to the 4 plus 6 times 10 to the 5 and so on. Oopsie. Plus 7 times 10 to the 6 plus 8 times 10 to the 7 plus 9 times 10 to the 8. So for any natural numbers, you can write it in this way. Okay? Oh, too many questions. And then you assume this is divisible by 3. So assume your natural number is divisible by 3. Then you can write this number. So let's call this n. Then you can write n as 3k for some k in natural number. Okay, and you know this whole thing equals to n, equals to 3k, sorry. So you know this equals to 3k. Okay, and then you take 1 from each of those. So the next step is take 1 from 10. So take 1 from 10. So sorry. So take 1 from 1 plus 2 times 1 plus 3 times 1 and so on, plus 2 times minus 1. That's gonna be divisible by 3, plus 3 times 10 to the 2 minus 1. That's divisible by 3 as well, plus 4 times 10 to the 3 minus 1, and so on. So you know that those are all divisible by 3. All of those. In fact, all of those. Wait, did I prove the other way around? Hold on, let me see. I feel like I proved the other way around. I proved this. I'm supposed to prove this. Did you guys see? This is proving if the sum of its digits is divisible by 3, then the number is divisible by 3. Because I was about to say this is divisible by 3. Bad. But it's the same thing because this equals to 3k, right? And those are all divisible by 3. Then you use this minus this. So you use a number divisible by 3 minus something divisible by 3. So you can reach the conclusion this is divisible by 3. That's it. There we go. Down. No, you don't reverse it. You don't reverse it. You move this side to the other side. So it becomes 3k minus a bunch of numbers that are divisible by 3. So this should also be divisible by 3. And this is basically the sum of its digits. Do you see? Oh, they don't change. They don't change. Just the last step, you move this to the other side, and you're done, basically. Because no, it's basically this. This is 1 plus 10. It's basically this, and then I distributed those. You see? I just use a random number to demonstrate the proof, because the proof itself is gonna take me longer, because you need to pick an arbitrary number, remember? So that's much harder. So I just used one number to demonstrate my proof. Yeah. The reason we're using this is because we know 10 to the power of something minus 1 is always divisible by 3. No, you cannot use numbers. Oh my god, I just said it. I just said the proof of this is too long that I do not have time to go over the whole thing. So I used a number to demonstrate the technique. But this is not a formal proof. Okay? It's not a formal proof. It's just a demonstration to show you how to prove the question. The proof, you need to write it yourself. It's pretty long because you need to be careful with everything. I didn't use induction. This question should be changed to something. This, I don't think they'll test you on this, but what they can test you on is they can tell you if a number, the natural number with, let's say 3 digits or 4 digits, something like that, then it will be much easier. It's the same technique, but you don't need to generalize it. So that's 102 level proof. Does that make sense? So 102 level proof would add a restriction here. For example, with 3 digits or with 4 digits, give you a specific number, then you just write it as like A, B, C equals to A times 10 to the 2 plus B times 10 plus C times 10 to the 1 and so on. Okay, next one. Question? So this question is too hard as 102, but if you add something, then it's doable for 102 students. You're so lost? Why are you lost? It's okay. Sorry, I apologize. It's normal to be lost. I need to watch out for my behavior. You might have a question like this. If a natural number with 3 digits is divisible by 3, something like that. It's not a hard proof, guys. It really is not a hard proof. Okay, I'm gonna move on to question 5 because this is what Dariya want me to do. So let's do what she wants. Okay, so A. What is A? Anyone tell me what is A? How do we do A? It's not a test review, it's just a tutorial. I'm just following Daria's tutorial. It's not a test review. How do we do? This is not gonna be on your test. Yes, you will not be tested on this. But how do we do this, guys? How exactly are we gonna do this? This equals to sum in 10. So 10 plus 1, 10, multiplied by 11 plus 1, 11, multiplied by 12 plus 1, 12, and so on, until we reach 99. So that's 11 over 10, or 10 over 11 times 11 over 12 times 12 over 13, and so on till 99 over 100. And you can see that those canceled out. So this is 10 over 100, which equals to 1 over 10. B. What's B? I'm getting bored. This is boring. This is not induction, but this is kind of boring for me. So we have 2 plus 1 minus 2 plus plug in 3, 3 plus 1 over 3 plus 1 minus 1 over 3 plus, and so on until you reach 19 plus 1 over 19 plus 1 minus 1 over 19. So this is what? This is 1 over 3 minus 1 over 2 plus 1 over 4 minus 1 over 3, and so on. Okay? Why do you guys sound like you know me very well? Don't think anyone's paying attention anymore. Okay, it doesn't matter. I don't care. Those canceled out. Which canceled out is what canceled out next? This canceled out. But those two, which canceled out? Which one's gonna cancel out with what? This will cancel out. Okay, so what do we have? We have minus 1 over 2 plus 1 over 20, which is what? What is this? Come on. Minus 9 over 20, exactly. I'm really bored. Okay, quickly finish the last one and let's just move on, okay? I'm bored. Let me change this. How do I do this? What is this? What is this equal to? That's a constant equals to 100, exactly, that's 100. Then you can move the 100 out. What is this? What is this? This is not 10. This is not 10. What is this? It's 1 to 10. What is the formula for that? Is 1 plus 10 times 10 divided by 2. Okay? This equals to what? You need to know the formula, yes. This is, yes. Down. Down, 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 down. I'm bored. This is boring question, boring question, boring question. This is boring question too. This is the only fun question, but I don't know why you guys are lost. Do you want me to prove with 3 digits? Okay, we have 4 minutes. See if I can finish it. I have another tutorial right after this. So let's prove this. Simple, it's really easy. Sorry, I just realized I said it's easy again. That's bad. Sorry, it's not easy. Oh, okay, let's prove this. Let's let be a 3-digit natural number and prove if n is divisible by 3. Actually, I'll prove one direction, but I'll ask you to prove both directions. Prove n is divisible by 3 if and only if the sum of its digits is also divisible by 3. Okay. See, the whole class cheered up. I like fun questions too. The summation question is boring for me as well. So don't tell Dariya. Okay, don't tell Dariya because she made the questions. So don't tell her. I love you, Dariya. So let's prove this. To prove even only statement, you need to prove both direction. So you need to prove this direction and also the backward direction. So let's prove the first direction first. So let's assume n is divisible by 3. Then we can write it as 3k. For some k in, well, this is natural number, so we want it to be natural number as well. Okay, now assume n equals to, assume n equals to xyz, xyz. Okay, where x, y, z is in this set. Wait, x cannot be 0. X can only be 1 to 9. But yz can be 0. Okay. Now n equals to z times, let's say 1, or z, let's just z, plus y times 10 plus x times 100. Okay, this looks easier for you guys, I hope. Then this equals to y times 10 minus 1 plus 1. Okay, or let's say 9 will be easier for you, probably, easier for you to understand. Because if I use anything not to number, you will freak out. 99 plus 1. So this equals to z plus y plus x plus 9y plus 99x. Okay, we know that n equals to 3k, so 3k minus 99x minus 9y equals to x plus y plus z. So you can factor out a 3 if you want. So 3 times k minus 33x minus 3y equals to x plus y plus z. So the sum of its digits is divisible by 3. That's the first direction. Question? Let's see. I feel like what happened in this? Oh, okay, I'm running out, I'm passing time, sorry. Zoom in, zoom out. Okay, cool. Like this. And the second part is left as an exercise to the reader. Prove it yourself. Is Dariya back? Is Dariya here? Is Dar here? Dariya's here. Sorry, Dariya.
I'm here. I'm eating.
I have to go, so you take over. I'm gonna go. Bye. Well, if you can leave it for as exercise for the grader for sure, but we cannot guarantee you're not gonna get 0. Or I can guarantee you'll get 0. Sorry. Bye.
Thanks, Lee.